Hi and welcome. I'm trying to learn biochemistry. Today, solutions, colloids and suspensions. And after that we're going to do leg injury prevention training. And if you participate in the leg injury prevention training, then it's better at risk. Solutions, colloids and suspensions. A mixture is a combination of elements or compounds that are physically blended together but not bound by chemical bonds. That explains things. What we're saying is, if it would be bound by chemical elements, it would be probably a new type of thing. Something new would come about. But they are just mixed together, they stay separate. If you bake a cake with sugar and you don't heat it properly or whatever, you can see at the end that just with sugar crystals, they never merged really with the dough or with a meal. They're staying single. So you can mix them together if you bake, but they don't form a new element. They mix together, and if you eat them, you do eat it part, and it seems like you eat a sweet cake, but it's actually never really blended together. Okay, a mixture is a combination of elements or compounds that are physically blended together, but not bound by chemical bonds. For example, the air you, I mean human beings, are breathing is a mixture of gases, mainly nitrogen, oxygen and argon. Three common liquid mixtures are solutions, colloids and suspensions. What did we want to say as the air thing? For example, the air a human breathes in is a mixture of gases. What we wanted to say? That the air is a mixture. It is not a new element. The air is not a new element. It is a mixture of things. Air itself is not an element. Air does not exist as an element by itself. And it is not a new chemical bond or whatever. It is a mixture of things, and we have never properly mixed. Water has probably, I think. But air not. Do we say it? We say air is a mixture, not a new element or a chemical bond. It is just nitrogen gas or oxygen gas and argon gas. They are mixed but not bound together. Three common liquid mixtures are solutions, colloids and suspensions. Okay, that's why we're here. Solutions, colloids and suspensions. Now, in a solution, a substance called the solvent dissolves another substance called the solute. Let's see that. Usually there is more solvent than solute in a solution. Okay, get the whole part. That is solution. That is the whole thing. For example, your sweat, I mean a human being's sweat, is a dilute solution of water. That's the solvent, plus small amounts of salts, the solutes. Okay, the solvent is the big thing regulated. The solvent is the big thing in which it is dissolved. It makes sense. Solute sounds like just sounds like a small thing. The solute is the salt, and the solvent is the water, and the whole thing is a solution. Once mixed together, solutes remain evenly dispersed among the solvent molecules. Solutes, we're saying the salt, remains evenly dispersed among the solvent molecules. And the solvent is the water. So as we had with the cake, the sugar is probably, to all if it's good, mixed, it is probably the sugar in all places where you don't find a place where it is not sweet, but it is not bound together, but it is evenly everywhere mixed. And they stay together. Because the solute particles in a solution are very small, a solution looks clear and transparent. I think we're talking now about a solution which happens to be clear and transparent. I don't think if we would talk about our cake, that would be the case. Is there a transparent and clear cake for which you can look through? Maybe something or sugar even. Because the sugar may be visible. Okay, basically what we're saying is, it is so good mixed that you can't see it. A colloid is something else. Okay, a colloid differs from a solution mainly on the basis of the size of its particles. Okay, The solute particles in a colloid are large enough to scatter light, just as water droplets in fog scatter light from a car's headlight beams. For this reason, colloids usually look translucent or opaque. Milk is an example of a liquid that is both a colloid and a solution. The large milk proteins make it a colloid, whereas calcium salts, milk sugar, the lactose, and other small particles are in solution. Okay, that makes sense. There are some things, milk consists of many different things, and some things are completely dissolved, so it is a solution. But there are also other things which are not dissolved to the point where they don't scatter light in it, so they are basically invisible. And these are the milk proteins, and they are visible, and therefore milk is not translucent. The large milk proteins make it a colloid, whereas calcium salts, milk sugar, and other small particles are in solution. In both solutions and colloids, the solutes do not settle out and accumulate on the bottom of a container. What the meaning is that not one of them are heavier than other ones, I think. I don't know the explanation. Basically what we're saying is they don't, if you would let it stand for some time, they don't accumulate at some place. Now what happens now with milk if you let it stand? I don't know, but it must be then something else. And it seems also to be something else. In a suspension, so what we're saying is, in a colloid and a solution or whatever, they don't settle down. They are not some stuffs which sink down and stay on the bottom. In a suspension, by contrast, the suspended material may mix with a liquid or suspending medium for some time, but eventually it will settle out. We're saying it is there for quite some time. If you put soil or whatever, or sand, it stays there, but it sinks then down, and it does not stay forever mixed together. Blood is an example. Okay, we're talking now a bit about blood. Blood is an example of a suspension. When freshly drawn from the body, blood has an even reddish color. Okay, after it sits for a while in a test tube, the top layer appears pale yellow. This is the liquid portion of blood called plasma. The plasma is the liquid blood, which is both a solution of ions and other small solutes and a colloid due to the presence of plasma proteins. Here we're saying blood is properly mixed together, it is a liquid, but if you let it settle for a few hours or days, then you see that it has turned around. At the top there's now more yellow, because the other things have some down or whatever. At the top there's now a blood plasma, and that is yellow. And that blood plasma is a solution of ions and other small solutes, and a colloid due to the presence of plasma proteins. Okay, the yellow part on top, the plasma, now after having the blood standing there for a few days, is a solution because there are ions and other small things in which are still completely mixed perfectly. But there are also some colloids in it, because there seem to be other things in it. Blood is pretty complex, it makes sense. Other things in it which are mixed, but scatter the light, which are visible. I think that is with the colloids. We're going to read this later again. And red blood cells that have settled out of the suspension drift to the bottom of the tube, making the lower layer look red. And the red blood cells, they have sunk down. And the blood is now more red at the bottom, probably also. The concentration of a solution may be expressed in several ways. We're going to read that later. I don't know, this is we're going to read later on. That was so far the biochemistry part 2, solutions and colloids and suspensions. Well, where were the suspensions? These were the suspensions. I was wondering where we suddenly had that name from. Suspensions, the suspended material. Okay, suspensions. That was a part of biochemistry. If you were here for biochemistry, you can go directly to the next part of biochemistry. If you stay here and participate in the leg injury prevention training, then this will be good. We're having a good standing leg, and we're swinging the other leg to the side and the front. And the other leg. Swing it in front and to the side. And stand again on the first leg and bring the foot in front and back. Front and back. And the other leg, foot in front and back. And next exercise, breathe in, lift one leg up. Breathe out the leg to the side. Breathe again in. Out leg into the middle and down. Breathe in the other leg up. Out the leg to the side. Breathe again in. Out the leg into the middle and down. And now breathe in the leg up and the hands out. And go with the hands over to one side. And over to the other side. And now also with the legs over to the other side. And to the other side. And the same with the other leg. Hands out, leg up. And go with the hands out to one side. And to the other side. And now with the legs over to one side and with the hands over to the other side. And change. And in the middle. Down. And now lift one leg up. And press with the knee up and to the side. Up, to the side. And with the other leg, press up to the side. Now white cat, I think. Stand good on one leg. This exercise can go to the knee. So stand good on one leg. Turn over to the leg slowly. Go down. Turn over to the other side. And up. And again. Stand good. Turn over to the leg. Go down. Over to the other side. And up. Other leg. Stand good. Turn over. Go down to the other side, and again up. And again, stand good, turn over, down, turn again over, and come up. And the next exercise, the clock of this exercise can go again onto the stand good, and go with one foot always to the 90-minute intervals on an imaginary dial of the clock. Go always with a knee a bit down. And now, with your leg in front, 12 o'clock and 1:30, 3, 10:30, 9, and also 7:30, 6, and 4:30 and 3. And now, one hand on the tummy, one on the lower back, and lift one leg in a straight line up. Flex the foot and try to bring the leg higher. Control with the hands that you don't fall back. Try to bring the leg higher. And pull the leg up, point with the toes down, relax the leg. Other side, one hand on tummy, one on lower back, and lift the leg up in a straight line. Flex the foot, try to bring the leg higher, control with the hands that you don't fall back. And pull the leg up, point with the toes down, relax the leg. And next exercise. Don't do this exercise if you're pregnant. Have a good standing leg, the other leg with the heel into the ground, the third heel off the ground and place it again on the ground. And on the other side. Lift the heel off the ground and place it again on the ground. And the next exercise is stand. One leg up and down. And the other one up and down. Now you can do a horse. Leg in and out, in and out. You can do a camel, where the whole body goes up and down. And we have also another one where the whole leg swings. So the 1 for 3 if you like again. And with the other leg, you can do a horse. And out. Or the camel, whole leg, And the body. Another one, the legs, please. And we're ending legs wide apart, breathing out on. Breathe in, close the legs. And breathe again out. That was the leg injury prevention training. Thank you very much. And until the next time.